that number that is being approached is known as the natural base. It was also first used by the Swiss mathematician Leonhard Euler. Does that name sound familiar?
Yes.
It should.
Leonhard.
No, the Euler.
His last name
His last name does. I haven't posted on it in forever because I totally forgot. But that's the Instagram account for this class. Kenny's Rising Oilers was named after this guy.
What?
The Instagram account I have for this class,
Are you sure it's pictures of us? Looks like
it's definitely Euler.
I
Huh?
didn't think it was pictures of us. I didn't even, what?
Yeah, early on I keep forgetting to post. But I mean I should. But yeah, I usually like to post at least once a week, and I've just been teaching 2 brand new classes on block systems. It's been rough. But yeah, I told y'all at the beginning of the year that there was a Instagram account. Told y'all to let me know if you didn't want to appear on it, so I didn't take a picture of you. None of y'all told me that. Huh?
So it's called Mr.
No.
Kenny's Oiler.
It's called Kenny's Rising Oilers. Leonhard Euler was probably I would say one of the most famous mathematicians in the 20th or 18th century, not 20th obviously, but probably one of the most famous mathematicians ever. He developed this number. It became known so widely that we actually call it Euler's number, E, Euler's number. But it's also known as the natural base, which is an important part of logarithms that we'll get into starting next week.
You should have like the sleeper of the week. Like whoever sleeps most in class, take a picture of them,
That's
put
what
it on
I
the
should do.
Instagram.
I don't think that would go very
Sleeper
well.
of the week.
Any questions? Do we understand this number a little bit? The whole point is that as this k approaches infinity, right, that number gets closer and closer to Euler's number, so that irrational number e. And we're going to use that number. And please hear me very clearly. I'm going to say e in class. As soon as I say e, you need to think 2.718, at least 3 decimal places. Just like pi, everyone knows 3.14. Pi is not just, hey, here's this letter, it is a number, 3.14. E, when I say that, it's a letter that stands for an irrational number, because that irrational number is so important, you need to think 2.718. Okay? Keep that in mind. There's an explanation in the textbook about how we go from, so we have this compound interest formula, which by the way, this is also in your Big Ideas graphic organizer. So A is equal to P times 1 plus R divided by K raised to the KT. That's compound interest, or periodic compound interest. I would make sure I write this down right next to this to compare it against. A equals P times E raised to the RT. What is that E taking the place of? Yeah. So notice, where did that E come from when we started compounding how regularly? Constantly. So this is not periodic compounding, this is, let's not even say interest, periodic compound formula, because it works in stuff beyond interest. This would be continuous compound formula. Now I'll go ahead and tell you, if this shows up on understanding checks or tests, I will give you the formula. You have to know how to use it because we have got to move into logarithms soon. Okay? So what do we mean by P for this continuous compounding formula?
Oh, that starting amount.
So the initial value is the mathematical terms that we use for that. What do we mean by E? Nope. I just went on a tirade about this. You got to know that as soon as I say the word E. There we go, 2.718. Which, does it stop there? No, it keeps going, but that's where we're going to approximate it to. Euler's number What does the R stand for, you think?
Interest rate.
Okay. We'll say, I just don't want to say interest because it can be things other than interest, but we'll say the rate. Yeah, let's just say rate. R for rate. And if we're talking about money, it would be an interest rate. But this is actually the formula we also use when it comes to carbon dating and other things like that. Those are known as, why are you looking at me like I'm crazy?
I've never heard that one before.
You've never heard of carbon dating when it comes to like dinosaur bones and figuring out how old things are.
No.
My mind is blown right
I've
now.
never heard the word, but how do they even do
I've
that
never-
when it
I've
comes
never
to
heard
like
of
natural disasters? Like they test a rock at the bottom, but then like some big would.
They can identify different isotopes of certain elements, and because we know the rate at which those elements decay, they can identify how old it is. That's actually what they do. But they use this formula actually, and they know the rate at which things decay.
You said true like you wanted that.
And
More like
T is
true
equal to
like
the time, usually in years, but T is time.
If I can't tell me, I wouldn't know either way.
Yeah, let's just quickly do this. So, and we're gonna, yeah. So, number 9 has us looking at her investment if it was compounding continuously at a rate of 6%. So, A of T would equal what? What's gonna come first? 500? Then?
Times 1
Or
plus.
2.71.
So we're just gonna we're gonna write what down instead of E.
You.
Why is it E instead of the 1 plus?
Because it's continuous.
It's continuous, right? And that's the thing we want to remember. When it's continuous, we're using that 2.718. Okay, so E there raised to,
0.06.
there we go, 0.06.
Times 1.
If we're only looking at 1 year, but let's do T since we're going to do 1 year and 5 years. So let's find A of 1 and let's find A of 5.
If I put E in the calculator, is it gonna do it right or do I have to?
You do not want to type E from the letters. Can I see something real quick?
Isn't it from like the
Okay. Anybody have a guess where on the calculator we could get to the number E?
The pi.
The pi button, right? Pi is the irrational number. You should see an E there as well when you hit the pi button. And so that's what will allow you to access Euler's number.
Or what's G? What's G?
Gradients. It deals with angle measures. I believe, don't quote me on that. I've never dealt with gradients actually.
I'm gonna quote you on that.
Don't do it. Alright, what's A of 1?
530.92.
530.918.
918.
And because we're dealing with money, I will at this point do 9 too. So was that very different than when it was compounded yearly? No, right? Even compounding it continuously, I didn't even get a whole dollar more. There's a limiting factor. Okay, what about A of 5?
674.929.
So 929 would be 93. And so that's a little bit more than what we got doing it just yearly, but not a ton more, right? It'll add up over years, but within a year it doesn't add up that much. Huh?
It's still like $100 more almost.
No. Look at what it was 5 years earlier,
Oh, that's too much.
right? 5 years
Oh.
earlier here, wasn't it? Yeah, 664, so it's like $10 more. Yeah. As I said, it'll add up over years, it won't add up a ton short term. Okay, so let's look here. The given functions are sketched on the coordinate plane shown below. Label each function. So what we want to do is we want to label where f of x is, where g of x is, j of x, and k of x. One of these should be super quick to identify. Anyone know which one it is? Why do you say the fraction one? Fraction, let's see.
Because that just looks like it's less than 0.
Less than 0?
plus, I don't know.
The fraction
Fraction
in
is
between
It's
zero
so
and
small to me.
the fraction decays.
Well, does a fraction always decay? It's not less than 0, it's less than 1. Remember, if it's less than 0, it's a negative. We don't want negatives, right? Okay, so if the base is less than 1, it's a decay. So which one is j of x? So let's number them 1, 2, 3, and 4. Which one is 1, right? So here's my j of x right here. Cool. All right, we got j of x out of the way. How am I going to figure out the other 3?
I would like it
steeper if it's
no.
Say it again, Cameron.
Would it be steeper if it's a higher number?
Would it be steeper if it's a higher number? Let's think about it. If I look at, so you're thinking like g of x might be the steepest?
I don't know, yeah.
I mean, that's the higher base, isn't it? So let's look at g of 1. Remember, this is what some of y'all were stressing about, but this is something we should be thinking about. To get the points on the graph, we need to plug inputs in and get outputs out. What is 3 to the first? That's 3. So where do we see a point 1, comma 3? Right, 1, comma 3. So this must be g of x. So does that match Cameron's idea that the higher the base, the steeper the graph? Yep.
So then the next one will be the 2 of x. wouldn't it?
Well, f of x, 2 raised to the x. Okay? So 4 must be k of x. And notice, what point do they all have in common? That's not a point. Don't you dare. 0, 1, thank you. We got to break that habit. It is not a point if it's only a y value. Alright? So look at part B. Consider the function m of x equals e raised to the x. Use your knowledge of the approximate value of e to sketch its graph. Well, what point do we know it has?
2.10.
0, comma 1. It has to have that point, right? 0, comma 1. Remember, everything has 0, comma 1, because what's e raised to the 0? 1. Anything to the 0 is 1. Now, from the next detail, is going to be a growth or decay? Okay, so I need to start on the left-hand side and come up through here, right? Okay, where do you think it's going to fit on the right-hand side? Is it going to fit in between any of those? Is it going to be taller?
In
In between g of x and f of x, right? E is approximately 2.71828, yada, yada, yada. So it's got to come in between 2 raised to the x and 3 raised to the x. That's got to be m of x. Notice we can use our understanding that e is somewhere between 2 and 3 to approximate some of these details. And I love the fact that Cameron picked up on the detail that, hey, if that function has a higher base, it's going to be steeper. Right? That higher that base, the steeper it is. Alright. We're skipping 2.3. That means Monday when we come in, we're going to start on the inverse of logarithms. Really quickly, what do you have tomorrow? An understanding check, right? What is that understanding check on? Stuff?
All the stuff we're supposed to understand.
What that is?
Am I ever gonna need volume 1 again? No. Can I throw it away?
No.
Oh.
You
It
need it
doesn't
for
fit in my
studying for your
backpack.
final.
I wish this was my longest class. My longest class is like the
Don't put up your calculators yet. You should be getting a poll question. There we go.
So how is the interest rate of people who have money smaller than the interest rate of those who owe it? Like, how does that even make
Because
sense?
if someone owes you money, you're gonna make sure they pay as much, you want them to pay as much as possible, so you set a higher interest
Well,
rate.
yeah, but how does it, I'm like,
Say again? You didn't get it? Hey, really quickly, you might wanna take a picture of this. These are some of the things to think about for features of a polynomial function to analyze. I also need you to make sure you bring me back that practice today, because I need to give you feedback so that you can study with it tomorrow before your understanding check. You want to pay attention to some of these things. I will put the homework up in just a second and go back and forth between this and your homework.
how is there, like, is there like a, like worldwide, like, set thing? Because like, I get if DJ owes me money, I can make him pay
All right,
back,
good.
but like, between countries, how does it work?
Say again.
Between like countries, how could you do, you can't just be like, oh, I gave you $1 billion, now you owe me like 52
Well,
cents.
so like before someone borrows money, you'll set an agreement of, hey, you'll pay me back this interest rate. Hey, here's the homework. Here's the homework. Does anybody need to take a picture of this? Because notice we need this stuff done with the graphic organizer. Good talk. Anybody need me to put the big ideas back up there? Put the big ideas.
You taught me something about privacy.
Do you? You know what a lot of people joke that a CD is? A certificate of depression. Do you want to know why? Because the interest rate will never match inflation. So you'll actually always lose out on money on a CD. It's better for you to long-term find someone to invest money for you and invest it in the stock market.
That's what I always do. But isn't the point of the interest
I'll put it
rate
back
so
up
that
in a
they can never owe you back? Because let's say America owes somebody this much money and then another country attacks us, that person's gonna be like, hey bro, they owe me money, you can't attack them, and then they defend us?
Thank you.
Is that like the point?
Say that one more time.
Like, let's say we owe China
Yeah.
a lot of money, and then somebody attacks us, China's gonna be like, bro, they owe me money, you can't take them out.
Say again. We did stuff out of the textbook. If you look at the videos, you'll see it on the videos what we did out of the textbook. I can send you the slides. Do you have an email address? Do you check your email? Have you been getting the emails I regularly send out? No? Write your email address down really quickly. You do get my emails? You sure? Write down your email address just to be safe, and I'll send you an email of the slides. Did you get an email from me last night? Okay, so yeah, you're getting the emails. I'll send you an email with the slides so that you know roughly what we're covering, okay? Which we won't have covered everything in the slides each day, but that was like the plan, okay? But we covered stuff out of the textbook. Do you want me to put the graphic organizer back up? Yeah. Okay. Oh, there is also, so you missed this for sure then. So this is the assignment that I was talking about that's due today. I gave it out earlier this week. And then in class, I had students work on an understanding check. I don't know where it went off to though. But I'll send you a copy of the understanding check as well, okay? David. Hey, David. You did so much. You better not do it.
I'm getting a calculator.
Okay.
But I looked up is Georgia gonna beat Alabama? It said, believe Alabama will beat Georgia.
Okay. I don't know about all that. I don't give us much of a shot.
Georgia Park gonna be, is gonna get Alabama run for the money.
I think Georgia's gonna beat Alabama hard. I think it's gonna be an unfortunate time.
Anybody sees Jay